Okay, let's do an elasticity of demand problem. So let's imagine that demand is given the variable x and price is given the variable p. And the relationship between demand and price is given to us by x plus 500p is equal to 10,000. So I want to study elasticity of demand, that is how demand changes the relative rate of change in demand compared to the relative rate of change in price. Right? We know that as I increase price, my demand is going to drop. We want to study this relationship. So let's write this as a function of price, giving us the demand. Right? If I solve this relationship for my demand for x, I find that x is equal to 10,000 minus 500p. So I can only have a positive price. So let's put 0 there. This is my price axis. So as I increase my price, my demand drops 500 and it begins at a value of 10,000. Right? This is really just a straight line and a slope. For every $1 change in my price, I drop down 500 people or 500 units. Okay, so let's study elasticity. The elasticity will also be a function of price, and it is defined as minus p times f prime of p, the rate of change of the demand equation, right here, divided by the value of the demand, right? Divided by the value of this function. So all we have to do is plug it in. So minus p, f prime of p will be the derivative of the demand function, 10,000 minus 500p, and I divide by the derivative, or sorry, the actual demand function, 10,000 minus 500p. Now this will simplify. The derivative of that expression is just minus 500 by the power rule. And I still have this 10,000 minus 500p there, which we can go ahead and simplify. I have 500p on top and 10,000 minus 500p on the bottom. And I can actually go ahead and simplify even further. I can take a 500 away from everything here. So if I do, I'm left with a p in my numerator, and 10,000 divided by 500 yields me 20 minus p. So this is the most simplified expression for the elasticity of demand. Right? How does my demand change as my price changes? So now I can evaluate this elasticity equation at certain values. So let's look at the elasticity when the price is equal to 4. So that will be 4 over 20 minus 4, or 4/16, or 1/4. Meaning that as your price changes, your demand is 1/4 as likely to change, or it changes 1/4. So a conclusion that we could take is if my price measured in dollars increases by 10%, right? Because the elasticity equation gives you a relative rate of change in the relative rate of change of demand to the relative rate of change in price. So if my price increases by 10%, that is going to imply that my demand, which here is equal to x, let's not introduce d. My demand is going to decrease by 1/4 of that amount. So 1/4 of 10%. Or 10% over 4. Right, we can simplify that a little bit. 5 over 2%, or 2.5%. All right, so a 10% increase in my price yields a 2.5% decrease in my demand. Therefore, it would be profitable if I increase my price, because I could increase my price by 10% and I would only lose 2.5% of my demand. So it's a pretty good trade. Let's look at the elasticity at the price point of $10. So this will be 10 divided by 20 minus 10, or 10 over 10, or 1. So I can reach a similar conclusion. If price measured in dollars is increased by 10%, that is going to imply that my demand is going to decrease by the exact same amount, right? The ratio is 1, so they grow and change at the same rate. So if I raise my price by $1, then my demand is also going to decrease by whatever 10% of that population is. And then we could study the elasticity at the price point of 16. So that is going to be 16 divided by 20 minus 16, or 16 over 4, or 4. So the conclusion here is if I increase my price by 10%, that is going to make my demand decrease by 4 times that amount, or 40%. Right, so here would be an instance where you don't want to increase your price, because if you increase your price by 10%, then you lose more than that in your demand. Your demand actually drops by 40%. Okay, hope you found this helpful.